you guys should have a handout that has 4 graphs on it. 2 on the front, 2 on the back. Does everyone have that? We're going to use that today when we do transformations. On the top, it says parameter changes. That's transformations. Same thing. So when we graph quadratics today, we're going to compare them and see what the different numbers are doing or what effect they have on our graphs. So the first 2 that we're going to compare are on my screen. If you would copy down these 2 onto your notes, please. It says y equals x squared and y equals 2x squared. We're going to compare these 2 graphs. And before we go any further, I want you guys to grab a marker. You don't already have one. I want you to grab a marker. And if you want, you can use a pencil for one graph, or we'll use a marker for another. If you've got a pen, you can use that too. But I do want you to use 2 different colors so that you can easily compare these. Having 2 different colors. You can use a pencil and a pen, you can use 2 different color markers, I don't care. But you need 2 colors, please. So we're going to go ahead and on our calculator, we're going to graph these. We're going to type in y equals x squared. So go to your graphing calculator if you would. Where do we go to type in our equation that we want to graph? Y equals. Now, clear anything else? Is there anything in there to start? It's already locked up. Alright, so we should have y equals x squared typed in. Let's go ahead and go to graph so we can see a picture of what this graph is going to look like. So click graph. Does your graph look like mine? Alright, so let's start by graphing this parabola on our note sheet. So pick one of the marker colors, one of the colors that you're using, and sketch in a parabola. Right now you should be sketching a picture of the parabola y equals x squared, that's the one we just graphed, on your notes handout. Anybody have any graphing issues? Alright, so we're going to compare this graph that we just sketched on our notes to the second graph. Let me get this.
You want it on the same?
Yes, we're going to put them on the same grid. And if you would, before you go any further, let's label this line. So this line is y equals x squared. Even though we're doing it in different colors, it will help you later if you've got a label. So when we sketch our second graph, we're going to do it in another color, whether it's a pencil or a pen or another marker color, I don't care. Now this time we're going to graph y equals 2x squared. So go back to your graph, go to y equals. Now do not clear out that first graph, don't clear out the x squared. Leave it in there because we want to compare them. I'm going to hit the down arrow, and that's going to bring me down to y sub 2 equals. This is the second graph that we're going to draw. So our equation again is y equals 2x squared. So we'll type in 2x squared. Where do we go to see a picture? Graph. Now remember, you could always, go to zoom standard if your view window's not the same. Now my second graph is in red. I did it backwards on my otherwise. My second graph is in red. How would you describe or compare that second graph to the first one that's in blue? Kevin?
Steeper.
It's steeper. What else could do we use to describe just? Narrower. Anybody else have a different word they may use? I really like the narrower because that tells me that it's. I want you to use steeper when you're talking about slope. That's a perfect word. If you're talking about a linear equation, about steeper. But for quadratics, I like Justin's description of being a little bit narrower. I'm going to sketch in my second graph. Now these are just sketches. I'm not expecting you to have a perfect parabola drawn in, but I do need you to do a couple of things. Your vertex, that bottom of that graph, needs to be at 0, 0. And the second graph that you draw needs to be narrower than the first one. And I want you also to label. So multiplying by 2 made it narrower. Remember, these are a parabola, not a V, not an actual diagram. So it does say to describe the shift, so we'll say the graph of y equals 2x squared is narrower than y equals x squared. When we compare two things, I do need you to mention something about each graph. Now I'm saying that our second graph, the y equals 2x squared, is narrower than the first one, which is sufficient. Okay, here's our second two graphs to compare. So let's go ahead and sketch the first graph. We know what that's going to look like, don't we? Y equals x squared. We just graphed it. So go ahead and sketch in a graph of y equals x squared. And also label it. And we just sketched that on our calculator. We graphed it on our calculator. Catch that one pretty easily. Now for the second graph, y equals x squared plus 1, we're going to type that into our graphing calculator. So go back to your graphing calculator. We're going to go to y equals. Now I don't want to clear out the first one, do I? Because I'm using that to compare. So let's leave that one in there. Go to the second graph down here to y sub 2 equals. And I'm going to clear that out. Now here, let's type in x squared plus 1. Go to graph to see a picture. There's the first one. There's the second one. What effect did that plus 1 have on our graph? It shifted it up 1, didn't it? Okay. What if it had been plus 2? Up 2, what if it was plus 10? Up 10. So if we're adding a number to our x squared, that's going to shift it up, isn't it? Any guesses what might happen if we're subtracting a number from x squared? Maybe down? Okay. So on your notes sheet, make sure when you draw your second parabola, y equals x squared plus 1, that you start your vertex, that's the point of your parabola, the bottom there, is at 1. It needs to be at 1. I'm going to be really picky on that. I don't want you just sloppily shifting it up. I want to make sure that you understand that it's at 1. So let's describe. It says describe the shift of the graphs. So the graph of y equals x squared plus 1. What are we going to say? Well, more specific. I don't want it just went up or it's higher. I need specifics. It shifted up 1 unit. Please don't just say it went up. I want to know that you understand that that plus 1 shifted it up 1 unit. Alright, so let's just go back through. We multiplied by 2. What did that do to our graph? Made it narrower. We added 1. What did that do to our parabola? It shifted up 1. Okay? Here we're but we have the negative. Any ideas what that's going to do? Think it's going to shift it down?
Shift it down.
Well, let's try it. Let's go ahead before we graph it. Let's go ahead and sketch in what y equals x squared looks like. No, that one was. So now we're ready to go ahead and graph the second one. We're going to go to y equals. The first y sub 1 equals, we're going to leave that there. We're going to arrow down to the second one to clear that out.
What's the second one?
All right, in the second equation, we're going to go ahead and type in negative x squared. When you type this in, make sure you use the negative key down here below the 3. You use a minus, give you a hair message, I believe. So go to graph then. All right, I graphed it upside down, didn't it? What's a word that we could use? A flip?
Reflection.
A reflection. Either one of those words would be good words to use to describe this transformation. This is a reflection of the big kid word. Flip, you could say flip, but the more technical word that we would use would be reflection. No, just a flip. Are you guys labeling your graphs? Okay. It'll be more useful to you later if you've got them labeled. So let's describe here what is happening. We can say the graph of specific. Instead of just saying a reflection, it's a reflection over which axes? Which axes are they reflect over? So the graph of y equals negative x squared is a reflection over the x axis. Now let me ask you guys a question. What if it had reflected over the y axis? You're thinking it would be like this sideways? No?
It just be like this.
We're going to take this purple problem, and we're going to reflect it on the y-axis. So this side's going to go over there, and this side's going to go over there. It's going to look exactly the same, isn't it? You'll see more things like that in Algebra 2. In Algebra 1, our big thing is identifying that reflection over the x-axis. Let's keep going. We have one more, is that right? Okay. Now this kind of got distorted when I opened up the Active Inspire. So the second equation is really that. So we have y equals x squared, and we're comparing it to y equals 1/2 x squared. Before you graph it, do you have a prediction? You mean like a shift? Okay. We're not adding a half, we're adding one, shifting it up one. What do you think? Maybe wider? Okay, possibly. Let's graph our original function. We call this a parent function. Y equals x squared is called a parent function because that's our basic graph. So let's go back to our calculator. Go to y equals. We'll leave y sub 1 there, and then y sub 2, we're going to clear that out. And we're going to type in 1/2 x squared. 2.5. I'm going to use parentheses on my 1/2. I could also use 0.5 there. There's our parent function. So y Now, why is this one wider, but multiplying by 2 is narrower? Wouldn't you think multiplying by 2 would make it bigger, make it wider?
Let's talk about the slope.
But it's not linear. I feel like you can't talk about slope. Think about something for a second. I'm gonna go back real quick so I study it. If we were to do a t-chart and pick values for x, we're going to put 0 in for x squared. So 0 squared would be 0 times 2, 0. Put 1 in. 1 squared is 1. 1 times 2 is 2. That's making that number bigger, isn't it? Put 2 in. 2 squared is 4, and 4 times 2 is 8. It's getting bigger. Put 3 in. 3 squared is 9. 9 times 2, 18. It's making it bigger. Multiplying by 2 makes it bigger, doesn't it? It doubles all of our y values. Now, if you think back to the one that we just did here, 1, 2, and 3. No 0 is going to be 0. So let's put 1 in. 1 squared is 1. When you take it times a half, what's it going to do? It's going to cut it in half, isn't it? Make it half of what it is. Half of 1 is 1/2. Put 2 in. 2 squared is 4. 4 times 1/2 is 2. It's making it smaller, isn't it? So when you plot these points, over 1 and up a half, over 1, over 2, up 2, you're not going, your y values aren't as big, are they? So it's going to make your graph wider than it would be. We could try 3. 3 squared is 9. 9 times a half, 4.5. These numbers are smaller, so our graph is going to be a little bit wider. And again, make sure you do label. So let's describe our shift. So the graph of y equals 1/2 x squared is wider than y equals x squared. There's lots of different things we can do to our problems. Today I'm going to give you some problems to compare. In your calculator, when you're comparing, make sure you leave your first equation in y sub 1, your second equation in y sub 2. When you're comparing things, be specific. Don't say shift it up. Shift it up how many units? Be specific.